let's start with low pH is acidic and high pH is basic. So in the scale 0 to 7 to 14, in between you can put 5 and 10, right? And then let's explain. 0 to 7 is acidic and 7 is neutral and 7 to 14 is basic. But the 10 area can be considered as weak base and the 5 area can be considered as weak acid. So 0 is strong acids and 14 is strong bases. So strong acid, weak acid, neutral, weak base, and strong base. That's the scale from low to high. So we're going to decide this one in using pH. It's also simply we say power of hydrogens. So that means how many protons, what's the concentration, square bracket, to show the concentration of protons. The highest protons around 0 pH. Okay, and then around 5 pH, it's a little bit lower proton concentration. Neutral is also low, middle, right? And then even 14 pH has a tiny bit of protons. You see, that's the red triangle I'm showing to you. Okay, now we're going to use hydroxide ion concentration. It's sort of opposite, and then it goes from low to high, right? But try to remember the red triangle. And then strong bases have a lot of hydroxide groups, and the neutral area has proton and hydroxides equal amounts. So that's why it's neutral. So H plus is equal to hydroxide ion concentration at pH 7. That's neutral. And also the red and the blue triangles show that, right? But I would try to memorize the shape of the red triangle and the pH numbers. So good example is strong acid is HBr, HI, HNO₃, HCl, sulfuric H₂SO₄, perchloric HClO₄, and the hydrochloric we're gonna break into ions, dissociate into 100% H plus and Cl minus. And therefore, if we do a simple calculation, you can convert, let's say we start with 1 molar HCl and it should give you 1 molar protons. If you start with X molar HCl, it'll give you X molar protons, right? Very easy because it's full dissociation, 100%. You start with 1 mole, you end up with 1 mole proton, right? So that's why they are called strong acids. It's not stronger, they are called strong acids, right? And then also the moment it forms ions in the water, it becomes strong electrolytes. So strong acids, strong dissociation, strong electrolytes, and fully ionized. Okay, so those are the features of those strong acids. You just have to memorize them, right? Those 5. And then let's take the strong bases, potassium hydroxide, sodium hydroxide, and those are actually first and second column in the periodic table, the hydroxides of those metals, right? So the KOH we can dissociate into fully K plus and hydroxide ions, and it's 100% dissociation. That's why they become strong bases. So the first column and second column hydroxides of the periodic table are strong bases. They dissociate fully, making strong electrolytes, right? Similarly, you can break calcium hydroxide and to give you calcium 2 plus and 2 hydroxide ions. So look at the stoic here, right? Okay. Now, also, if you start with X molar calcium hydroxide, you're going to end up in this case 2 X molar hydroxides because of the coefficient, right? Because of the formula. And so just know how to do that one so you can get the pH eventually. So the strong bases also strong electrolytes and they ionize fully, right? Now let's look at the weak bases. That's around 10 pH. And then the weak acids around 5 pH, and the neutrals are at 7, and those are examples of sodium chloride, water.